So welcome to another video. In this video we are going to discuss some example programs in relay ladder logic. So the first problem we are going to look at is we have this arrangement in which we want to pump some water from this position, this tank to this tank, the upper tank, through this pipe. A pump is connected here, and we will have a switch which is not shown here. We will have a push switch, and upon pressing the push switch once, the motor should start running and it should pump the water through this pipe and fill this tank. As it fills the tank, we have a float valve. Normally a float valve will block the opening like this, but here we want it to act like as soon as the water is rising, it should trigger a limit switch. This is a limit switch. We have a limit switch attached here. It will trigger a limit switch which will the output of which will be used to stop this motor. So that is our objective. Means this arrangement has to automatically identify when to stop the motor. So we will let's see how it works first. So started, and it will water start entering the upper tank. Water in the upper tank will start. The lower tank will to the limit switch. Now when it triggers the limit switch, the motor stops and this operation stops. So let's see how we can implement this logic using a ladder diagram. So this is the ladder diagram. So we have two rails attached here, L1 and L2. So this indicates, we already mentioned in the previous video, this indicates the positive terminal, and the blue rail indicates the negative terminal. We have only one rung. This is the horizontal line is called rung, and we have only one rung here, but there is a parallel connection here. So we are connecting a normally closed push button as stop switch. There is a normally closed relay attached here. There is a normally open push switch, and normally open relay, and finally a normally open coil which indicates the motor. When this coil activates, the motor will be activated. So if you let's look at the working of this ladder arrangement, and let's see that whether it works or not. So first we will push the start switch. We will push the start switch, and the current through this path, and the motor coil activates, and the motor will start running. But as soon as a path is established, as soon as the motor gets activated, here this coil we will connect it such that when this normally this output coil is activated, this relay gets also activated. So a parallel path is formed here. So current passes through both points at this point, and when we remove the force into the push switch, then it means that the push we only need to push the switch only once. So when we remove it, the current remains will continue through this path, and motor will keep running. So we the reason we connected the this arrangement in parallel is because uh, we only need to push the start switch once. Otherwise we will have to keep the switching in keep the switch in closed position, and we will have to continually exert the force. So we just want to push it once, and the motor will keep running through using the current flowing through this path. Now when we when the limit switch means initially the limit switch is not activated, so since this is a normally closed switch, this relay will be closed. So the output of the limit switch is connected to this relay, and when when the float valve triggers the limit switch, a high signal is formed, and this relay is energized. And when this relay is energized, the when this relay is energized, the contact breaks and the whole motor will stop. Also, when we push the stop switch, if we want to stop the motor in between, if when we push the stop switch, then also the circuit gets broken and motor will stop. So using this arrangement, we can get the operation we want, and this is the ladder diagram of that problem. Now we will go on to next problem, uh, in which we will see a multi-rung control. So in this example, there was only one rung. In the next example, we will see more than one rungs. So this is the example. So initially, this is a switch. Initially, this switch is in off position, and when it is in off position, the red light indicator will be activated. So this will glow and this will be off. So when we switch on the switch, the green indicator will get activated and the red one will be off. Again, if we switch off, then again red lamp will be activated. So how can we draw the ladder diagram for this arrangement? Let's see. We have two rails, L1 and L2. This will be the first rung. We have a switch, an ST switch, single pole single throw switch here, and we have connected an output coil. This is the rung 1, this will be the rung 2, and this will be the rung 3. So this will be the switch S, and this will be the control relay. Means this coil will energize these relays. So when the switch is open, this coil will not be activated. So uh, this coil will not get energized, and this will be open, and there will no current will pass through this uh, run. But since this is a normally closed switch, current will pass through this run, and red light, this indicates the red light and the red light will be activated. So when we close the switch, so here we can see that in this case, when in off position, this rung get activated and red indicator will be glowing. When the switch closes, rung 1 gets activated. Rung 1 gets activated and control relay coil is activated, which in turn will energize this control relay and this control relay. When this is energized, this since this is a normally open switch, it will close and this coil will get activated, which indicates the green light. When this gets activated, this gets energized. Since this is a normally closed switch, it will get open and the current will not pass through it, and so the red light will dim. It will be off. So again we can see that when it is in off position, the rung 3 will get again current will pass through this rung and this light will get activated.